Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najam, and I hope you all are fine in every aspect. So today's in AS Physics, we will learn about Kirchhoff law, and this is the most important law related about current and electricity. And in this unit, we will actually learn about recall and application of Kirchhoff law, that how can we apply this law, use the law to drive the formula for the combined resistance of two or more resistors in series and parallel, and even recognize that the ammeter are connected in series within a circuit and therefore should have low resistance, and recognize the voltmeter connected in parallel. Why we connect in parallel across the components or components, and therefore should have high resistance values. So in this particular topic, we do this, but before we start, you should know about the names of the meters you use to measure the current, just like voltmeter and ammeter. Circuit diagrams, how can we draw the circuit diagrams, and how to measure the potential difference of a component and the current in it. So this is our topical content objective today. So before starting the lecture, please note that you have to watch complete lecture till then to clear the concepts. And if you have any query, any questions, so you may ask in the comment section. And like this video, share this video with your fellows to clear their concepts as well. Okay, so let's start. All right. So that if we are talking about the Kirchhoff law, Kirchhoff basically an electrical engineer of his time, and he actually designed different kind of circuits by using different kind of components. And you should be familiar with the idea that the current may divide up where a circuit splits into two separate branches. And you know well, this is only possible because computers can be programmed with the equation which describe how current and voltage behave in a circuit. I think it is in the hardware. So these equations include Ohm's law and Kirchhoff's law. Kirchhoff's basically divided their statements into two parts, right? So first of all, that we're talking about the first law. First law of Kirchhoff. The statement is very simple, and the statement says that the sum of the currents entering any point in a circuit is equal to the sum of the currents leaving that same point. That is exactly like this is a wire, a copper wire, and that's your terminal point P. And if we allow current through this, so it will simply flow in a circuit. So in this particular diagram, we can say that the amount of current I1 must be equal to the amount of current I2 when it passes in a coil. But what about in this criteria, if I have the amount of current and if we try to pass through a junction, but this time it is divided into two splits. That's your I2, this is your I3. So actually, in this second figure, we have one current coming into the point Q and two currents leaving. So the current divides at Q, that particular point Q, equals the total amount of current, that is sum up the divided one, right? So Kirchhoff law is an expression of the conservation of charge. You can say that the initial charge must be equal to the final charge that we received. And this idea is that the total amount of charge entering a point must exit the point. To put it another way, in case of that, a billion of electrons, just like ऐसा तो नहीं होता ना कि एक दो तीन चार इलेक्ट्रॉन्स आ रहे हैं, billion of electrons, infinite number of electrons actually entered a point in a circuit. It is looks like the same as that कि हमारे घर में जो सॉकेट होता है, उस सॉकेट के अंदर जो चार्ज आ रहा है, हमें कैसे पता चलेगा कि once we insert a plug और उस प्लग के साथ कोई बल्ब लगा हो या कोई और चीज लगी हो, टेस्ट पॉइंट लगा हो या टेस्ट चार्ज लगा हो, so basically we can examine. So this law can be tested by connecting ammeters at different points, because ammeter is actually a device. Ammeter is a device which is connected in series in a circuit to measure the current value. So Kirchhoff law, as I say, can be tested by connecting ammeters at different points in a circuit where the current divides. So we should recall that an ammeter must be connected in series. So the current to be measured passes through it. Okay. So if I say one thing, that is formal statement of Kirchhoff's first law, that is summation of all current which is in equals to summation of all current which is out in a circuit. That the symbol This symbol is actually a Greek letter called sigma. That means sigma means sum of all, right? So sigma I mean sum of all currents entering into a point. This one, sum of all currents entering into a point must be equal to the sum of all currents leaving that point. Okay. So this is a sort of equation which a computer program can use to predict the behavior of a complex circuit. So what about the Kirchhoff's second law? The simple statement of the Kirchhoff's second law is the sum of the EMFs around any loop in a circuit is equal to the sum of all potential differences around the loop in a circuit. That is a simple statement of Kirchhoff's second law. Because we know well one thing, that the amount of voltage EMFs in a circuit is actually directly proportional to the current according to the Ohm's law, if you people remember. So just like in this circuit, we have a resistor R1 and we have a resistor R2. So actually, whenever the amount of current is passing through the circuit according to the EMF, so basically the current I must be same all the way around, and we need to concern ourselves further with the Kirchhoff's law. So according to this particular circuit, the Kirchhoff second law is an expression of the conservation of energy. That is very important. And that we are talking about the electrical energy. Okay. So we can say that the law can be applied and general categorize as per the any particular circuitry where we actually compare resistance values, current values, and the values of EMF. And the second thing that you should remember about the formal statement of the first law and the second law. The first law is statement, we have done it. But what about the second law? Second law says that the total amount of EMF and the total amount of voltage is actually equal. That means EMF जो हम प्रोवाइड कर रहे हैं उसमें से जितना EMF कंज्यूम होगा, पोटेंशियल बनेगा, पोटेंशियल डिफरेंस बनेगा, is actually the sum of the potential drops, right? So according to this law statement, the sum of the EMFs around any loop in a circuit is equal to the sum of the potential differences. PDS mean potential differences around the loop. That as we draw in the circuit, as we are talking about equation for Kirchhoff's second law, that is sum of all energies equals to sum of all potential differences. That is exactly the sum of the EMFs must be equal to the sum of the potential drops. And as per the formula, that is E is equals to V1 plus V2. But we know that according to Ohm's law, V is equals to IR. Okay. So V1 is equals to IR1 and V2 is equals to IR2. So I can easily write over here as E is equals to IR1 plus IR2. Or we may write like this, that's your I common, R1 plus R2. This is actually the statement of second Kirchhoff's law. So use Kirchhoff law to find the current in a circuit. Thus I'm drawing the circuit. So I have one resistor over here of 10 ohm, another resistor 30 ohm, and terminal potential over here. So over here, terminal potential is 6 volts, and over here, that's your 2.0 volts.
सर हम टर्मिनल एक बैटरी काउंट कर रहे हैं या दोनों बैटरीज को मिला के?
दोनों को मिला के।
सही।
मैं भी लूप डायरेक्शन बता रहा हूँ स्टेटमेंट को। And the loop is over like this. That's your flow of current. So a circuit with two opposing batteries. Okay, this is two opposing batteries. So this is a series circuit, so the current is the same all the way around the circuit. Okay, so first of all we have to calculate the sum of EMFs.
वो होगा ना?
Calculate sum of EMFs, that is 6.0 minus 2.0 is equals to 4.0 volts, because circuit हमारा opposing batteries के साथ है. Okay, now in the second part we calculate the sum of potential differences. We know where about the potential difference. Sum of PDs. So we have I multiplied by 10. This is Ohm's law exactly. V is equals to IR, right? Plus I multiplied by 30. One resistor is your R1. This is your R2. Okay. So this is 10I plus 30I. So total PDFs equals to 40I. So this is your EMFs. This is your PDs. So we know that sum of all equals to summation of all the PDs. So that is 4.0 is equals to 40I. Okay. So 4.0 over 40 is equals to I, and I becomes 0.1 ampere. So you people could have to solve this problem without applying the law, but you have to find that in more complex problems to avoid any kind of errors. Okay. So we can easily justify any proper circuit. Let's take another example. I'm drawing the circuit. Like that's my battery. That's a resistor, 10 ohm. This is a loop. There is another battery, 2.0 volt. Over here, 6.0 volt. And that's your I1, P junction point, I3, I2, I1, I2. So this is exactly the situation of the circuit. So Kirchhoff laws are needed to determine this kind of circuit. So the question is that they calculate the current in each of the resistor in the circuit, which is shown here. And we have already marked all the particular circuits. So we know that about the law, as we know, we have 3 loops over here. So the actual amount of current, that is your I3, because there's a loop. And after this one, there is I1 and I2, because I1 coming to the P and I2 is coming to the P. So that is exactly the situation according to the law. According to first law, I3 is equals to I1 plus I2. Remember the direction. Remember the direction, please. This one and this one. Okay. So choose a loop and apply the Kirchhoff law, second law. So we have to choose a loop along with this. So according to second law, after pick the loop, we have EMF is equals to V1 plus V2. Okay. So what is exactly V1? V1 exactly related about I3 and 30. यहाँ जो वोल्टेज होगा तुम्हारा, ये होगा तुम्हारा V1. ओके. और ये सेकंड रेजिस्टर के साथ जो होगा, ये वाला, ये होगा तुम्हारा V2. राइट. और EMF कितना है हमारे पास? 6. दैट्स योर E. तो 6.0 is equals to I3 multiplied by 30 plus I1 multiplied by 10. So this is exactly 6.0, 30 I3 plus 10 I1. Okay. So this is exactly your equation A. So repeat the step 3 with the other loop, this one. ये वाला जो दूसरा लूप बन रहा है हमारा, सेम यही काम इसके साथ करेंगे हम. Now EMF is 2.0 is equals to एक रेजिस्टर हमारे पास है यहाँ पे I3 के साथ, yes sir, I3 multiply by 30. This is your B. अब इन दोनों की वैल्यूज को उठा के आप रख दोगे साइमल्टेनियसली अपनी इक्वेशन में, ये वाली वैल्यूज के साथ. सो वी नो वेल, अगर मैं इसी को थोड़ा एलैबोरेट करके फर्दर लिखूं, सो कैन आई राइट लाइक दिस, और I2 is equals to I3 minus I1. Okay, so that is according to this equation, I2 is equals to I3 minus I1. So putting the values, I2 is equals to 0.0 0.067 minus 0.400. So we will get the value of I2, that is minus 0.33 amperes. Okay. So putting the value of I2 in the above equation, so we can easily calculate the actual value, that is sum of EMF 6.0 minus 2.0 is equals to I1 into,
जी
the negative sign indicates what? Negative sign indicates
ऑपोजिट डायरेक्शन में जा रहे हैं.
exactly. Negative sign indicates the opposite direction. To the arrow, right? So we could have applied Kirchhoff law to the outermost loop in a circuit. So which will give us, you can say, second equation. Second equation be like, जैसे हमने अभी पहले भी किया था कि ये जो हमारा EMF है, इन EMFs को हम क्या करते हैं, माइनस करते हैं, and then we can easily calculate the value of current I1. Okay, so over here another equation we can generate over like this according to the second law, that is for current I1 we can go for the EMFs, difference of the EMF, that is (6.0) minus 2.0 is equals to I1 into 10. This is the circuit. So over here 4.0 is equals to I1 multiplied by 10. So we can easily calculate the value of I1. I1 is equals to 4 over 10. So I1 is equals to 0.4 amperes. We have I2, we have I1. So we can easily calculate the amount of I3. For I3, that is I3 is equals to I1, that is 0.4. So I3 is equals to I1 plus I2. So the value of I2 is minus 0.33. Okay. So 0.4 minus 0.33,
0.07.
0.07 ampere. So this is exactly how to solve a circuit by using the Kirchhoff law. So one more thing you should remember about that, the EMFs combination, like starting with the cell EMF, we know that the EMF E1, E2 and E3, so सारे जितने EMFs होंगे उनको हम क्या करेंगे, कलेक्ट कर लेंगे, और टोटल सम ऑफ EMF जितनी बैटरीज आप करते हो, अब वो इस हिसाब से कि आप उसको अगर रिवर्स कनेक्शन पे लगा रहे हो तो वो हमारे पास क्या होगा, फिर माइनस से प्लस में कन्वर्ट हो जाएगा। सिमिलरली जो हमारे पास एंटी क्लॉकवाइज अगर हम लगाते हैं, ऑल द PDFs दैट डिपेंड्स अपॉन द अमाउंट ऑफ वोल्टेज जो कि ड्रॉप हो रहा है, तो दैट इज एग्जैक्टली देयर इक्वेशंस, राइट। As I say one thing at the starting, that the Kirchhoff second law is a consequence of the principle of the conservation of energy. If a charge of 1 coulomb moves around the circuit, it gains energy as it moves through each source of EMF and loses energy as it passes through each potential difference value, right? That means simple that the energy gained passing through the sources of EMF must be equal to the energy lost passing through the components with the potential differences. Okay, or on the behalf of that, we claim the formula of EMF, that is E is equals to W over Q, right? Or we may write the formula of the PD as same, V is equals to W over Q. So that is exactly, we made that unit 1 joule per coulomb equals to 1 volt. What is that? An EMF in volts, simply that the energy gained per 1 coulomb charge as it passes through a source. Similarly, a potential difference is the energy lost per 1 coulomb charge as it passes through the component. Right? So we can think as the Kirchhoff law said what? Energy gained per coulomb around the loop related to the EMF, that is energy loss per coulomb around the loop for your potential difference drop. So this is the actually the criteria for the conversion of energy relationship. All right. Now that's we are talking about resistors. Combination of resistors. So we connect resistors into 2 combinations. Number 1, resistor in series, right? And in series, we know well, all the resistors are combined in a single loop. Okay. Here we pass the amount of current which is same throughout the circuit. But what about voltage? It will be different in every resistor. R1, R2, R3. So remember that in series combination, current will be same in the circuit, but voltage will be different. So sum of the voltage will be V1 plus V2 plus V3, depends upon the resistors. As we know that V is equals to IR होता है. So V1 is equals to IR1, V2 is equals to IR2, and V3 is equals to IR3. Right? So if we connect all these values, that is V is equals to IR. So IR is equals to IR1, IR2, IR3. Taking common I, R is equals to R1 plus R2 plus R3. So we cancel down the R, I value. We will get series combination of the resistor. Okay. Resistors in parallel. What does it mean? That we have a resistor over here which is connected in a loop with another resistor, that is passing out the current, but it will be transferred through the circuit that's your R2, I2, I1. This is exactly the resistor connected in parallel. So we can use Kirchhoff first law over here. And remember one thing, in parallel combination, voltage is same throughout the circuit, but current will different on every resistor. Remember that voltage is same, current will be different. So according to Kirchhoff's first law, in which we discuss about the looping, that is I is equals to I1 plus I2. And we know well one thing, if you apply Kirchhoff's second law over here, if Kirchhoff's second law is applied, to the loop that contain two resistors. So here what we get, I1 R1 is equals minus I2 R2. That's the total sum of equals to 0 volts. Because आपका I EMF क्या हो जाता, यहाँ पे cancel हो जाता. The loop if would be like this. Then what is exactly happening according to the Ohm's law? That is V is equals to IR, right? And I is equals to V over R. So I1 is equals to V over R1 and I2 is equals to V over R2. So if you're applying this, so I is equals to I1 plus I2, V over R is equals to V over R1 plus V over R2. So we can take V as common. So 1 over R1 plus 1 over R2. V2 we cancel. So 1 over R is equals to 1 over R1 plus 1 over R2. This is the parallel combination of a resistor. Now you should know one thing, that the ammeter and voltmeter, the ammeter and voltmeter are connected differently in circuits. Ammeters are always connected in series since they measure the current in a circuit. Okay. For this reason, an ammeter should have a low resistance as possible so that little amount of energy will be dissipated in the ammeter itself. Right? And what about the voltmeter? Voltmeter measures the potential difference. Voltmeter measures the potential difference between 2 points in a circuit. And for this reason, they are connected in parallel, that is between 2 points. Usually it is connected parallel with the bulb, just like in the figure 9.22. So they should have a very high resistance to take as the little amount of current is possible, right? And the ideal resistance of a voltmeter would be infinite, very high resistors. Nominal voltmeter having 25,000 ohms resistor. So basically, voltmeter have typical resistance about even 1 million ohms and so on, 10 million ohms and so on, just for measuring the 2.5 volts. So this is exactly the circuit criteria of the voltmeter and the ammeter you should remember whenever you perform experiment in the lab. So that we have done today, and I hope you understand all the concepts. So meanwhile, inshallah, in the next session, we will discuss about the resistance and the resistivity concept, and also solve the numerical analysis of the same unit. So electrical measuring instrument, ammeter, voltmeter, oscilloscope. The oscilloscope can display rapidly changing voltages, right? So that's enough for today, and that is your reflections of the lecture, right? And here is your summary. That is exactly we learn in this unit. So that's enough from my side. Kindly like, share, and is there any confusion? So you may comment down below. And if you want to learn any specific topic, so you may write the name of the topic, either AS chemistry, A2 chemistry, AS physics, and A2 physics, right? And also share this lecture with your fellows. Okay. And please subscribe the channel if still you are not subscribing but watching the lecture, and also press the bell icon to get notifications timely. Take care. Fi amanillah. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.